welcome to GER Hub. In today's video, I shall be discussing applications of binomial expansion. Please smash a like on the video and endeavor to join my community by clicking the join button and joining the community on any level of your choice. That being said, let us begin this video with telling you 3 applications of the binomial expansion. Number 1, the binomial expansion primarily can be used to expand binomials. Number 2, the binomial expansion can be used to approximate. Okay? And number 3, you can also use the binomial expansion to predict terms. So you can use it to predict terms of an expansion. And I would add a 4th one to predict coefficients. So let's start with expanding using binomial expansion. Now, if you have not watched my previous video, my last video on binomial expansion, I would encourage you to click the link in the description that will take you to the first video I made on binomial expansion. So let's start with expand. Okay? Now, this is what I'm going to do. Let's start with a general problem. Now, if you watch that video I made earlier on binomial expansion, you will come to see the meaning of what I'm actually doing in this video if this is your first time of watching or learning binomial expansion. So let's start with expanding a binomial of this nature that carries the power n. Now, in that video I told you that in binomial expansion the coefficients are always combinatorial in nature, and as you expand from left to right, that is from left to right in your expansion, please take note that the first variable starts after the coefficient with the highest power, and the second variable starts with 0. Now, as you move from left to right in the expansion, this first variable, which starts with the highest power, will keep diminishing by 1 as you move from term to term from left to right. But the second term, y in this case, that starts with 0, will keep increasing by 1 as you move from left to right in the expansion. Another thing I told you in that previous video is that at every term in the expansion, the sum of the 2 powers for each variable must sum up to the total power, in this case n. So let's see how to expand this. I'm going to use a general example such as this and use a specific example also to expand. So let's start with, we are under using binomial expansion to expand, which is the primary essence of using binomial expansion. So let's start. Now let's do it with me. So the first coefficient will be n combination 0. So n combination 0. And this coefficient will carry x raised to the power of n, and when this one starts with the highest power, the second term will start with 0. Now please take note, n plus 0 gives you n. That is just to confirm that at each point in time, the sum of these 2 powers would add up to the total power, and the combination or the combinatorial coefficient start with n combination 0, and this 0 will keep increasing as we move from term to term until it gets to the power n. That's where the expansion stops. So the next term will be n combination 1. Okay, now notice that my 0 has increased by 1 to 1, and this will now diminish the power to n minus 1, and this will increase to 1, from 0 to 1. Now take note again, n minus 1 plus 1 will give you n, just to confirm what we said earlier on. Now the next expansion or the next term will carry n combination 2, in which case take note, 0 to 1, 1 to 2, we keep increasing by 1 for the combinatorial coefficient, and this would diminish. The power of x will diminish again by 1, and that will give you 2, and this would increase by from 1 to 2, so it will increase. Now the next one, if you go along, will be n combination 3, and I'm doing this intentionally. Ordinarily I will stop here and add ellipsis, but let's see. So this will be x in power diminishing by 1 again, so it reduces to n minus 3, and this will become y raised to power 3. At this point again, take note, the sum will give you n. So if you continue this expansion, it will get to the second to the last term. In addition, at the second to the last term, this 0 which became 1, that increased to 2, that increased to 3, it will keep increasing until you get to the term, the value before n, and the value before n is n minus 1. So you would actually get to a point where you have n combination n minus 1, and at that point your x would have been 1. It would have reduced to 1, and y would have increased from 0 through 1 through 2 through 3, it would have increased to n minus 1 for the second to the last term in the expansion. And finally, the last term would be when 0 has finally gotten to n. So the last term will have a coefficient n combination n, and you will have x raised to the power 0 here. At that point, x has reduced from 1 to 0, and you end up having n. Take note, n plus 0 gives you n minus 1 plus 1 gives you n plus 0 gives you n minus 1 plus 1 gives you n minus 2 plus 2 gives you n minus 3 plus 3 gives you n. So this is the expansion of x plus y raised to the power of n. Now, if you want to simplify further, you could simplify n combination 0. If you followed my last video, I told you anything combination 0 is 1. So this will be 1. X raised to the power n comes in, and y raised to the power 0 will be 1. Okay? Plus n combination 1 would be, anything combination 1 will give you that same thing. So n combination 1 should give you n. So let's see, just to confirm, n combination 1, which can be written as this, is n factorial all over n minus 1 factorial and 1 factorial in this case. So, and this will give you n times n minus 1 factorial all over n minus 1 factorial times 1 factorial, which is 1. So this will cancel to give you n. So this will give you n times x raised to the power n minus 1 times y raised to the power 1, which is y. Plus, if you go to n combination 2, n combination 2 will be n combination 2, which is n factorial all over n minus 2 factorial, and 2 factorial, please take note, is 2 times 1 times 0 factorial, which is 1. So that will be 2 times 1 times 1, which is 2. So this will be n factorial giving you n times n minus 1 times n minus 2 factorial. You stop at that. N minus 2 factorial, 2 factorial, which is 2. So this cancels. So you end up having for this n into bracket n minus 1 all over 2. Okay? Or you could just leave it as 2 factorial if you don't want to simplify. So this will give you times n raised to the power n minus 2. Let's bring the terms here. And this will be y raised to the power 2. So for n combination 3, it will be n times n minus 1 times n minus 2. So I'm going to bring that here. N times n minus 1 times n minus 2 all over 3 factorial. And 3 factorial, please, is 3 times 2 times 1 times 0 factorial, which is 6. So you could have 6 here, and x raised to the power n minus 3, y raised to the power 3, plus, bring your ellipses and come over here. N combination n minus 1 will give you n. I told you in that particular video I made that anything combination 1 short of itself is the thing itself. So n combination n minus 1 is n. And that will give you n times x raised to the power 1, which is x, times y raised to the power n minus 1. Okay? Now please take note, if you know how to do this expansion, it will help you when it comes to differentiation. You will come to meet this when you do calculus. When you start doing calculus and you want to look at how to derive the formula for one of the general formulas in first principle of differentiation, you would need to know about this. Okay, so this is very useful. Now, plus n combination n. Anything combination itself, I told you, is 1. So n combination n is 1. X raised to the power 0 is 1 by indices, and this is y raised to the power n. So let's now write out our final result for this expansion of x plus y raised to the power n. So our final result will be 1 times x raised to the power n times 1, which is x raised to the power n. Please take note again, you will need this expansion in first principle of differentiation under calculus. So this will be n times n minus 1 all over 2, x raised to the power n minus 2, y raised to the power 2, plus n into bracket n minus 1, n minus 2, all over 6, x raised to the power n minus 3, y raised to the power 3, plus ellipsis, plus n x y raised to the power n minus 1, plus 1 times y raised to the power n, which is y raised to the power n. And this is the expansion for x plus y in bracket raised to the power n. So that is for expansion. The application of binomial expansion is primarily to expand. So we have expanded using the binomial expansion, a general example. Let us now look at a specific example. What if you were given these guys? What if our n was a particular value like 4, and you have 2x here plus y. Okay, it is very simple to get this done. So let's look at this as a B problem under the first application, that's expansion. So this will now be 2. I'm going to start with 4 combination 0. Okay, so you start your combination that way, 4 combination 0, and you bring your first term 2x to carry the highest power 4, and you bring your second term y to carry the power 0. Okay, now plus, we move now from 4 combination 0, we will move one step further to 4 combination 1, and 4 combination 1 will now multiply 2x raised to power 3, and this will be y raised to power 1 at this point. So this decreases from 4 to 3, and this increases from 0 to 1. Now you move again to 4 combination 2, and 4 combination 2 would have 2x raised to power 2 here, and this will be y raised to power 2. Now take note, at every point this must add up to give the total power here. So take note to show that you're correct. So this will be 4 combination 3. Now at 4 combination 3, we have 2x carrying the power 1, and y would carry the power 3. Again, take note of that. The sum adds up to give the total power, plus finally 4 combination 4, where the expansion stops. 2x now will carry the power 0, and here it will carry the power, y will carry the power 4. Again, take note of this, it has to give the total power. So you now simplify, all you have to do is simplify. So 4 combination 0 is 1, because anything combination itself is anything combination 0 is 1. So I'm going to write 1 here, times 2x raised to power 4 is 2 raised to power 4 by indices times x raised to power 4. So 2 raised to power 4 is 16, and x raised to power 4. Then y raised to power 0 is 1. Anything raised to power 0 by indices is 1. So plus 4 combination 1 will give you 4, because 4 combination 1, anything combination 1 is that thing. So times 2x raised to power 3 will be 2 raised to power 3 times x raised to power 3, which is 2 raised to power 3 is 8. So this will be 8x cubed times y raised to power 1, which is y, plus 4 combination 2 will be 4. Okay, 4 factorial all over 4 minus 2 factorial, which will be 4 times 3 all over 2 factorial, which is 2, times 2 raised to power 2x raised to power 2 will be 4. This will be 4. So this will be x raised to power 2 times y raised to power 2. Then come to the next one. The next one will be 4 combination 3. 4 combination 3 would obviously be 4. Okay, because 4 combination 1 short of itself will give you 4. So that's a better way to put it. So 2 raised to power 2x raised to power 1 will be 2x. So I'm going to bring this. Then y raised to power 3, I'm going to bring that there. Now plus, let's come over here. So 4 combination 4, anything combination itself will give you 1, times anything raised to power 0, 2x raised to power 0 is 1, times y raised to power 4. Now let's simplify to get our final answer. So all you have to do is 1 times 16x raised to power 4 times 1 will give you 16x raised to power 4, plus 4 times 8 is 32, so I have 32x cubed y, plus 4 times 3 is 12. So this would end up 2 can divide them 4, so that will be 6 when you multiply that 2 with 3. So 6 times 4 will give you 24. So let's get it done at once. So that will be 24x squared y squared. Now let's go over to the next one. 4 times 2 is 8, so I'm going to bring my 8 here. Then x times y cubed. Then the last will be 1 times y raised to power 4, which is y raised to power 4. So this gives you the expansion for 2x plus y raised to power 4 using binomial expansion. Let us now go to approximation. So binomial expansion can be used for approximation. How can you use binomial expansion to approximate? In what kind of problems? We call it approximation, but please just look at it this way. So what if you would encounter problems like this? Expand or approximate 2.04 raised to the power of let's say 3. So this can be a problem solved using binomial expansion. If you are to solve this problem, this kind of problem, 2.04 raised to the power of 3 using binomial expansion, all you have to do is to write the problem out. 2.04 raised to the power of 3 will be equal to 2 plus 0.04. Okay, Notice what I have just done. I have just decomposed this problem to look like a binomial where the 2 becomes my x and this becomes my y. Okay, so the problem reduces to x plus y raised to the power of 3. Now, I'm going to put it here. The first one will be, the coefficient of the first term will be 3 combination 0. And the first term will be 2 carrying the power of 3. The second term will be 0.04 carrying the power of 0. Plus 3 combination 1. The first term will be 2 raised to the power 2 now. And this will be 0.04 raised to the power 1. Okay? The next one will be 3 combination 2. And this will be 2 raised to the power 1 because it decreases in power to 1. And this will be 0.04 raised to the power 2. And the last term will be 3 combination 3 times 2 raised to the power 0, 0.04 raised to the power of 3. Now, once you get this done, you can now simplify. And the question may tell you to approximate this to the nearest, to 2 significant figures, 3 significant figures. What I am trying to emphasize here is that in such problems, all you have to start with doing is to decompose this fraction into the sum of 2 numbers. One number would be the whole number and the other one will be the fraction, okay? And when you do that, you can now apply your normal sense or knowledge of binomial expansion. So 3 combination 0 will give you 1. So 1 times 2 raised to the power 3 is what you have here. 0.04 raised to the power 0 is 1. Anything raised to the power 0 is 1. So then 3 combination 1 is 3. Because anything combination 1 is itself. Times 2 raised to the power 2 is 4. Times 0.04 raised to the power 1, which is 0.04. Now, this will be, the next one will be 3 combination 2, which is 3 combination 1 short of itself, which will be 3. And this will be times 2 raised to the power 1, which is 2, times 0.04 times 0.04. Okay? Now, the last one will be 3 combination 3, which is 1, times 2 raised to the power 0, which is 1, times 0.04 raised to the power of 3, which is 0.04 times itself 3 times. Okay? So we can finally simplify the problem or conclude the problem here by saying 1 times 2 raised to the power 3 times 1. 2 raised to the power 3 is 8. So 8 times 1 times 1 is what you have here. This will give you 8. Plus 3 times 4 is 12. So 3 times 4 is 12. And 0.04, you can actually write 0.04 as 4 over 100. Plus, so I'm going to put this as this. Now, 3 times 2 is 6. So I'm going to write this as 6 all over. 0.04 is 4 over 100. 0.04 is 4 over 100. So this will be times 16 all over 10,000. Okay? Plus, that's what I'm going to do. Plus, 1 times 1 is 1. And then that will be 1. 0.04 is 4 over 100. So I'm going to write there 4 over 100 times itself. That will give you 4 over 100 times 4 over 100 times 4 over 100. That will be 64 over 1 with 6 zeros. Okay? So that's what you have. Now, whatsoever you get as your value, 8 plus 4, this should be 4 times 12 is 48 over 100. 16 times 6 will be 96. So I'm going to write here 96 over 10,000 plus 64 over 1 million. So when you simplify this, the result to this will give you the approximation of this. Let's try one more on approximations. Now please take note, this was just to show you how to go about approximation problems. In this case, we have not simplified the problem to the latter or the last. So the problem may require you to give your answers to 2 decimal places, so you can do that when you get there. Okay, so let us look at another problem such as 1.45. okay, 1.45 raised to the power of 4, for instance. You may be asked to get this done. So what do you do using binomial expansion? You write it as 1 plus 0.45. Okay, so turn it to a binomial. This particular expression 1.45, turn it to a binomial to become 1 plus 0.45, and the next thing you do is to now apply binomial expansion, which will be 4, the total power combination 0, 1 raised to the power 4 times 0.05 raised 0.45 raised to the power 0, plus the next coefficient will be 4 combination 1. Here 1 drops power from 4 to 3. This will be 0.05 4.45 raised to power 1 plus this will be 4 combination 2. This will be 1 raised to power 2. This will be 0.45 raised to the power of 2. Take note, 3 drops to 2 and 1 increases to 2. At the end of the day, the balance between the powers will give us the total power plus. Now coming over here, you have 4 combination 3. 4 combination 3 would have 1 raised to the power of 1 times 0.45 raised to the power of 3 plus finally 4 combination 4, 1 to the power of 0, it drops by 1, and this will be 0.45 raised to the power of 4. Okay, so what you now do is to simplify. 4 combination 0 is 1, so this is 1 times 1 raised to the power 4 times 0.45 raised to the power 0 is 1, plus 4 combination 1 is 4. Okay, so this will be 4 times 1 raised to the power 3, which is 1, times 0.45. The next one will be 4 combination 2. This will be 6 times 1 raised to the power 2, which is 1, times 0.45 squared. Okay, plus 4 combination 3 will be 4 combination 1 short of itself, which is 4, and that will be 4 times 0.4 times 1 raised to the power 1, which is 1, times 0.45 raised to the power of 3, plus 4 combination 4 is 1, yeah, times 1 raised to the power 0, which is 1, times 0.45 raised to the power 4. Let's now go to the third application. We say the third application is to predict terms of an expansion. So let's see. Take for instance, in binomial expansion, not all the times will you be asked to expand, not all the time will you be asked to approximate. Sometimes you may be asked to predict a certain term in a particular expansion. So let's assume that we are required to tell the fourth term in the expansion, of x plus y raised to the power of n. So to do this is common sense. Now in the expansion of x plus y raised to the power of n, let's come back to what we have done earlier on. So now this was term 1, this was term 2, this was term 3, this was term 4. Now please take note of what is happening in the fourth term. In the fourth term of this expansion, all you have to do as your solution is to tell us that, number 1, by observation, when you get to the fourth term, the question is what will be the coefficient. The coefficient of the fourth term to start with will be the total power combination 1 short of the fourth term. So if you are looking for the fourth term, then at that point in the expansion, this must have been n combination 4 minus 1. Okay, so this will be n. I'm going to put n combination 4 minus 1, and this will be x raised to power n minus 4 minus 1. Okay, so and this will be y raised to the power of 4 minus 1. So it means that the fourth term will be n combination 3 x raised to the power n minus 3 and y raised to the power of 3. That will be the fourth term. So binomial expansion can actually help you predict the terms of an expansion. Now let us use this like a formula for predicting what the third term will be. So in the expansion of 2y raised to the power of 4, if the question was asked, what will be the third term of this expansion? All you would have to do for the third term, this will be 3 minus 1, 4 combination 3 minus 1, and I will now bring 2x raised to power, the total power again, 4 minus in bracket 3 minus 1, and I'll put here y raised to the power of 3 minus 1. Okay, and that will now mean that this will give you 4 combination 2, sorry, this should have been 4 combination 2, okay, and this will be 2x raised to the power of 3 minus 1 is 2, this will be 4 minus 2, which is 2, and this will be y raised to the power of 2. So this will be the third term of that expansion. Let's try it again. For another one, if you had 4x raised to 4x plus 3z raised to the power of 6, and you were asked to predict the fifth term, the fifth term would be 6 combination. Since you are looking for the fifth term, this will be 5 minus 1, and this will carry 4x raised to power 6 minus in bracket 5 minus 1, and this will carry 3z raised to the power of 5 minus 1. So what would you have as your fifth term? It will be 6 combination 4, and this will be 4x raised to the power of 6 minus 4. 6 minus 4 is clearly 2, and this will be 3z raised to the power of 5 minus 1, which is 4. So this will be the fifth term of that expansion. Let us go to the last application, which is prediction of coefficients. So if you were given 2x plus 4 and you were asked to predict what the coefficient, not the term this time around, the coefficient of the second term will be. The coefficient of the second term, take note, will be 4 combination 2 minus 1. Second term minus 1. And that will give you 4 combination 1. If you're asked to predict what the coefficient of the third term will be, again, it will be 4, the total power here, combination. Since they want you to tell what the coefficient of the third term will be, this will be 3 minus 1. Third term minus 1, and that will give you 4 combination 2. So please take note, this is how easy it is to know the applications of binomial expansion. Thank you for watching this video. Until some other time, do like, share this video, subscribe to the channel if you haven't subscribed, and endeavor to turn on your notification bell. Also do well to join our community, our YouTube community, by clicking the join button on any level at all. I welcome you to my community. Thank you very much. Good night.